Today we're going to add 2 more pieces of information to our ability to find statistics given samples of data. The first thing we're going to look at is sampling distributions and estimating. If you pick up your little half sheet on your notes, it says when you want information about a population, you rarely perform a census. We've talked about that time and time again. We will use sample statistics to estimate our population parameters. Now, if you think back at our cornfield activity that we did before, we did different types of sampling methods, and we, as groups, found sample means, and then we found the means of those means. We did data with our means. That's what we're looking at here. With a sampling distribution of a statistic, it's the distribution of values taken by the statistic and all possible samples of the same size from the same population. So when we did it in class, we had sample sizes of 4. They weren't all the same. We did have some that were 3. But for our sake, if we considered them all to be the same, then we took the means of those samples. So what we're going to look at today is when we focus on X bar, which is the mean of the sample, we're going to use that to estimate the mean of the population. Our question is, how can X bar, the sample mean from one sample, be used to estimate the mean of an entire population? Well, we're hoping that the sample was a simple random sample. That's always best whenever possible to help us reduce bias. What we're looking for with a sampling distribution of X bar is that it has a center at the mean. The sampling distribution of X bar is a normal distribution, and as long as that sample is large enough, usually we're looking at values over 30. Our sample size should be over 30. And we talked about that in class when we were looking at it. We said, okay, what happens as our sample size increased? Neither of our class sizes were over 30, so we were limited in that aspect. And the sampling distribution of X bar, it's going to have less variability than that population distribution, because when we look at our sample means, what they're going to do is average out. So if we think about the distributions of the heights of adult males, we've talked about that a couple times. We have very tall and very short males. But when we're looking at the means of those samples, it averages out. Those very tall heights and the very short heights will average out. And so when we look at those means, the sampling distribution is a normal distribution, but it has less spread due to the fact that we're looking at averages of those samples. And let me run a little applet for you. Let me clear this so we can start over. So at the top of this applet, it shows the entire population. And what we can do is we can pull samples from that. So let's say I pulled a sample size of 5. And so it's dropping 5. It's randomly pulling 5 and dropping that sample data. So then we're going to have our means of 5, and then our distribution means when we have samples of 25. So if I kept doing 5 over and over again, let's watch what happens. Means of 5, means of 25. Let's keep building those. And you're going to see, you're going to watch that. Now, it could take me a long time to go by 5s here. So as that sample that I'm pulling from is larger and larger, look what happens. Look how pretty the shape becomes. Let me pull 100,000 now. And now it's just perfect symmetric distribution here. But if we look at it, look at the ends here. Let me grab a picture of that. We can see these and these are not here, are they? Because what happens when we find the averages of those samples, which it was pulling slowly and then putting the averages here, pulling slowly and putting the averages here, we can see as we increase that size, we reduce the spread. And when we look at those sample means, it actually is reflective of the population. It just has a smaller spread. Okay, The next thing we want to look at is margin of error. Now, there are actually calculations to determine margin of error, and those of you that are in AP Stat have probably done a good bit more than we're going to do with this. We're just going to do some basic interpretation given margin of error. So this is out of your textbook, the examples we're going to look at today. They're on page 46 and 47. It says, imagine a polling organization is surveying 1,000 voters to find out how they plan to vote in an upcoming election. 58% say they're going to vote for Smith. And the survey has a margin of error of 3%. So if we kind of looked at that on the graph, here's our average, but the margin of error is 3%. So truly, that vote we can expect from our polling could fall within this interval because of the margin of error. So the margin of error of a random sample defines an interval centered at a sample in which the population percent is most likely to lie. So because of that, plus or minus 3, we'll go plus and minus 3 units from that center. So it's likely that between 55% and 61% of city voters plan to vote for Smith. Now, if he just or she just needed the majority vote, then we can say from our polling that our polling indicates that they would hit that mark. Now, the next example is on page 47. Students at a high school will vote on a proposal to start classes later in the day. I know many of you would like that. According to the survey of a random sample of students, so that's good, sampling method, 54% of the students agree with the proposal and 46% of the students disagree with the proposal. So that looks like it's 100% of the students were represented as either agreeing or disagreeing, so we don't have any in the neither. The survey's margin of error, though, is 5%. So does the survey clearly project the outcome for voting? Well, if we look at that graphically, if we start off with the 54% and go plus or minus 5, that takes us from 49 to 59. And so those are the ones voting for. Against, we would start at the 46 and this would go from 41 to 51. Now, if we look at this one starts at 49, this one goes all the way to 51. We have some overlap in here. And because those intervals are overlapping, this survey is not clearly projecting the outcome. So because that plus or minus 5% error caused an overlap in our data there, we couldn't clearly project the outcome for voting. Okay. So there are more examples in your book if you'd like to take a look at those. But your activities for today are 1, complete yesterday's application of standard normal worksheet. And then 2, we have a little bookwork for you. The bookwork is out of your textbook. It's on page 50, and it's problem numbers 20 through 26. If you happen to finish early, you are welcome to study for another course. Many of you have an AP test coming up that you could use this time. If you happen to finish early, just make sure you aren't bothering your neighbors. And we'll see you tomorrow.